We're back again to take another look at one of the wild parts that Titans of CNC brought to their Boombastic Show. And that's the huge hunk of aluminum programmed by Stewart and run on their Doosan DVF6500. Now, there's a lot of material that has to come off of this part, and that was done with a combination of 3+2 roughing paths and full simultaneous 5-axis roughing. Let's open up this file and talk about a few different ways we can leverage the power of Mastercam to efficiently rough this part.
Okay, so we have our part open with our fixturing and then our table for reference on the DVF6500. And what we're trying to accomplish here is to basically quickly and efficiently create our 3+2 and then our multi-axis roughing operations so that we can get to the fun stuff, right? We can get to the multi-axis operations, the semi-finish and the finish, and get into some cool motion. But we want to create these roughing operations in a way that we can come back later and make adjustments quickly and easily to this process if we didn't zero in on the exact production manner we wanted in the first go-round. So if we look at this file, we have a G54 already set up at the top of this part, and then we have a port 1 plane pointing in this port direction. So a really quick and easy way to split this up for 3+2 roughing operations is to divide it by the 5 pockets we have here on the sides of the part. And that's exactly how we're going to approach this with some OptiRough operations. Let's walk through a really good way to set up this first roughing operation. Now, the very first thing I'm going to do is actually create a stock model for my operations to utilize, to take advantage of, so we know where stock is and where air is when we come into the part. So I'll click on stock model and I'll just name this something like initial stock. And I don't want to apply a plane transformation to this, so I'll just leave this off. Now the initial stock shape is going to be a model, and I'll turn on level 2, and I've got this cylindrical piece of stock that I started with, and I'll select that. Now that's all we have to do here. Source operations, there are none because we haven't added any operations to cut the model against. So this purely represents our starting chunk of stock. And here I could even, let's say, assign it a different color, and maybe I'll make it a dark blue just so it's not such a boring gray color. Alright, so now I've got my stock operation that my first OptiRough is going to utilize. So let's create this OptiRough. So for model geometry, I'll set my wall and floor stock to 20 thousandths. And I'll triple click to select the entire solid body. So this isn't going to cut the entire part because we're going to add some limits in the next steps. But this is a really easy way to make your geometry selection and then zero in on what you want later on with different controls in OptiRough. For avoidance, I'll select the entire fixturing level, and notice that I left out these jacking screws here shown in the fixturing. These are fully modeled threads, and these are quite computationally expensive if we select them as bodies. And a good way to handle that, if you want to use this as actual avoidance in your part, is to create simplified versions of these threads to use for the purposes of toolpathing. Here I'd like to view the fully modeled threads because they look nice, and I'm lucky enough that I don't have to set them as avoidance, so we don't have to take that extra step. And I'll say just stay 200 thousandths away from all of my fixturing. We're going to skip toolpath control. We'll come back to that in a second. For the tool, we'll use this big 3/4 inch Core 5 end mill. And we're going to turn on stock and reference that first stock model operation that I created. Now let's jump back to toolpath control, and we're going to start setting limits on what this toolpath can touch. So we're going to contain it within the silhouette boundary of my geometry selection, but we'll compensate to outside, and we'll maybe add 2 inches as a compensatory amount. And what this will do is allow the tool to move around in basically a 2-inch band around our geometry extents, so it can get at the air regions outside of the part. I'm going to turn on skip pockets. And why I'm going to do this is I immediately see that I have some holes in each of these 5 areas that I'm going to apply the 3+2 operations in. And I don't want my tool diving into these holes. I'll probably process this with a smaller tool later on. So I can just say skip pockets smaller than 2 inches, and that should be enough to keep the tool from trying to go down there. Now another way I could handle this is to create cap surfaces and select those as part of my machining geometry and basically create a false ceiling that the tool will not drive through. But in this case, this skip pockets functionality is going to give me everything I need without creating any additional geometry. For cut parameters, I'll leave these step overs and step ups bigger than I would in real life, because we're just talking about how to create the toolpaths here and the concepts behind 3+2 roughing. So we don't need to get too deep into the minutiae of tool setup, which might be different for your circumstances. Now the last control we're going to put on this is the minimum and maximum depth this toolpath can hit. So right away, I'll just hit detect limits here. And this detects the minimum and maximum Z values of the geometry I've selected for machining and avoidance. Now the maximum depth is the one I want to adjust here, because I don't want to go down to the bottom of this part. So I'll right click in this field, I'll say let's select Z coordinate of a point, and I'll select somewhere down near the bottom of the pocket, just approximate. And I see I get a 1.818 value. Maybe I'll change that to a 1.6 value. Drive the tool a little deeper than I know these pockets extend to. And with that, we'll press OK, and we'll see what we get. Okay, so our toolpath is calculated, and we can see we're targeting just this pocketed area here. Now, one thing I immediately notice is that we've got helixes down into these pockets here. Now, we're using a large 3/4 inch end mill that can center cut. But if you were using a non-center cutting end mill or a shell mill or something like that, we could not have these helixes down into the pocket. So how would we avoid that? Well, if we went back into the parameters here, rather than a skip pocket smaller than value, we could say skip all pockets, and this is going to change the toolpath so it only cuts what we can get at from the side. So it's always side milling, and that's safe motion for, again, non-center cutting end mills, shell mills, inserted tools, that kind of thing. With this Core 5 though, we're just going to hog away everything we can possibly get to at this stage. Alright, so with that done, the next thing I'm going to do is create another stock model that represents the shape of the part after this first roughing operation. So I'll call this after first rough. The initial stock shape will be the initial stock model, and then the source operation to process it with is going to be that OptiRest that I just created. Now, there's a trick here to increasing your calculation time with this mill flutes only checkbox. So what does that do? Well, if we have this off, what happens is when we process this stock model, we are looking at the flute, shank, and shoulder of the tool itself, and we're also looking at the tool holder shape to calculate stock removal at every point in the tool path. If you have a complex tool or a complex holder, this can increase calculation time because you're looking at every single surface and component that makes up that tool and holder assembly. However, if you say did something wrong in your toolpath and your holder blows through a part of your stock, it's going to represent that gouge in the stock in the final stock model. Since I'm pretty confident I have a safe path here, I can go ahead and check mill flutes only. So this only looks at the actual flutes of the tool when calculating material removal. So this is not going to show me any holder gouges or collisions against my stock. But again, since I'm confident in the toolpath, I can knock some time out by turning this on. I'm also going to change the color up. Let's change this to, let's say, a dark pink. And what this is going to do is anywhere that the tool cut, it's going to turn that pink. And that'll stand out pretty well against the blue and show me exactly where that tool targeted. This isn't very important on the very first 3+2 roughing path, but once we lay down 5 or 6 paths on this and then we get into multi-axis roughing, it's going to give us clues as to what operation did what on this cylindrical part. Alright, so that's done calculating and I can see what I got here. Now, what I want to do is I want to apply this same process to the other 5 pockets, or the other 4 pockets, excuse me, of this part. And I want to leverage the work I've already done with this operation 2 and all of the parameters that I've set up to make this successful. So the first thing I would do is I would create my plane for the next 3+2 operation. And for this is really simple. I'll just drag out the dynamic gnomon and maybe I'll snap it onto this surface here. And I'll call this port 2 plane. And all we need to take from this plane really is the vector that gets us into this pocketed area. So now here's where we save some time. I'll right click and drag this op2 down and I'll copy it. And what I want to do is just change this up so that I'm machining the second port area instead of the first. And really simple to do. I'm going to go into my planes tab and I'll switch the planes to port 2 planes. And the only other thing I'll have to touch is this steep shallow limits here because I have a different Z origin for that port 2 plane. So I'll hit detect limits again and I get some random Z values because of the height of that plane. So I'll say Z coordinate of a point, maximum depth, and I'll come down here, negative 1.15, so I'll drive it a little deeper just like I did in the last operation. And that's it. For stock, I'm going to switch the reference and I'm going to reference my after first rough stock. So this will allow me to intelligently recognize some of the roughing that's already been done on the right side of this port area. All my model geometry, all my cut parameters, everything else stays the same. So I'll click OK and generate that. Okay, we've got our second operation generated there. Now we'll do the same thing. We'll create another stock model. And I'll actually create it below all this. And we'll call this after second rough. Our reference is going to be after first rough. We'll change up the color again. And our source operation is just going to be op4. Let's generate that and see what we get. And there we have our second result. So we can see the orange is what op4 grabbed and the pink is what op2 grabbed. And they're both intelligently entering from air based on remaining stock here. So that's as efficient as you can be with air cutting time versus actually in the cut. So this is the process that will apply to all 5 ports, and I won't show all that. We'll actually skip ahead to the multi-axis roughing, the secondary roughing in here. But one thing I wanted to point out was the way we built this with stock models and references is very robust. So if we go back and we change the stock shape at a later point in time, make it a bigger diameter cylinder, change the fixturing up a little, or even swap out the entire part itself and change the geometry, we're only making small changes to the selections in these toolpaths, and all the rest of the power is built into how these are interlinked. So it'd be very, very quick for us to adjust to in-process changes on the fly. So now let's skip ahead and we'll get into multi-axis roughing. Okay, so we're back and we've got all of our 3+2 roughing operations complete. And you can see we've got quite the pinata here with the end stock model that represents all of our 3+2 roughing operations and what's been removed. Now we're ready to dive into some of the fun stuff. We're going to throw a multi-axis rest roughing operation onto this part. Now, why are we doing that? What couldn't we get with the 3+2 operations? I've gone and I've created a plane to make a section view here so we can see what I'm talking about. If we look at the stock left in these pockets, the pocket floor follows the cylindrical shape of the part. But when we came in with the big 3/4 inch core 5, we couldn't get down into the sides of this pocketed area. So that's left quite a bit of rest stock that we definitely can't just plow through with our finish tool. So we have to handle this somehow. Now, we could come in with a smaller tool and the same 3+2 orientations, but again, we'd probably take a while and it'd take a lot of level cuts to dig down towards the bottom of this pocket. A really simple way and clean way to handle this would be to multi-axis rough this. So how would we go about doing that? I've taken the liberty of coloring some of these surfaces and preparing some things so that we can more easily set up our multi-axis roughing path. So I've colored in purple all of the areas that I want to touch with our rest roughing. And I've created this wireframe loop around the purple surfaces that will form a boundary for the operation. Let's launch into multi-axis pocketing and set up a multi-axis rough operation. For this, we'll use the 1/2 inch bull end mill with the 120 radius. For stock, we're going to use that After All 3+2 roughing stock. And here in cut pattern is where we're going to basically set up everything for this path. So we're already set to a roughing pattern, and we're doing dynamic motion in an offset from floor strategy. So this is going to take the floor shape, whatever you select for a floor surface, and it's going to offset it out in parallel increments to create the actual cut depth slices. For floor surfaces, I'm going to select these 2 floor surfaces that make up this pocket. And for part surfaces, this is where I take advantage of that purple coloring, and I'll use the color mask to just quickly select all of those surfaces. That's a pretty complex selection otherwise. I'm also going to turn on level 55 here where I have the cap surfaces. Note that multi-axis pocketing doesn't have the same concept of skip pockets that OptiRough does, so we do have to create that geometry to control this. I'll leave the depth step alone, and the maximum step over, maybe I'll increase that a little bit to 100 thousandths just for the purposes of showing off this toolpath. The last thing I'm going to do here is use that outer wireframe boundary as containment. This is going to restrict the toolpath to just this area of the part. Otherwise, it'll go after stock wherever it sees it, and it'll be pretty aggressive in doing so. So if we look at the tool axis control page here, it's totally blank. There's nothing to set here. And that's because this roughing path is entirely controlled by the surface normal vector of the floor surfaces that you select. So the tool is always being pointed normal to the floors. And if you want the tool to point a different direction, you have to either select a different floor or draw a different floor. For this path, this is super simple. These floors are pointed exactly the way we want. It's going to keep the tool pointed correctly even as it comes up these sidewalls here, and it's going to be perfect. So I'm going to hit OK and generate on this, and we'll come back in a minute because this actually takes quite a bit to generate on large models with large amounts of rest material. Alright, our calculation is all finished up and we can see the multi-axis roughing path that we got. Now we've got a couple of extraneous passes on the top of this port that we really want to remove in a production environment, and we can do that with stock to leave settings in the stock tab. But in this case, we're going to look at the actual pocketing areas where we see the majority of motion. And notice we're correctly helixing in from air just above the stock, and then we're also taking only nibble passes on the sides of these walls because the 3+2 has already hit those pretty efficiently. And if we backplot this, let's get down to the floor area. So this is true multi-axis motion here, and I want to get down to where we see the actual full step over dynamic motion. So here's one of those areas on the back pocket. Let's restrict this drawing. And you can see that we have constant step over spiral, a true multi-axis spiral, flowing outwards and respecting that surface vector off of the floor, and then getting as far as it can into the corners of those pockets, which will be pretty far because we've got a pretty aggressive bull radius on this end mill. So this is an excellent and super efficient rest roughing operation for these pockets that didn't take much time at all to set up. So this was a end-to-end example of a really robust workflow to use for setting up and programming your 3+2 operations that allows you to be flexible and fast down the line if you need changes once you get to the finished part stage. And all of this is designed to get you through this as quickly as possible, get the material off, and get you into those glamour 5-axis paths even faster.
Head over to the Titans of CNC channel to see some of the other demos from their Boombastic show. Thanks for following along with me, and make sure to subscribe to get notified of more advanced programming how-tos from Mastercam.